So this is question number 1 to start with. It says, prove by mathematical induction that the sum of the first n positive integers is given by the formula 1 plus 2 plus 3 plus, the list goes on and on until some integer n, and it is given by the formula. This sum is given by this formula n bracket open n plus 1 close bracket divided by 2. That is, we have to prove that this formula can represent all of the sum irrespective of whatever value of n you are dealing with. That is what the induction proof is talking about. Okay, so we'll move straight to the solution to see how to prove it. We already know, as I earlier mentioned, that basically there are 2 steps involved in proof by mathematical induction, but these 2 steps are further divided into 3 steps. Now the 2 steps are the basic step when n is equals to 1, and then we have the inductive step, which also is subdivided into 2. That is the assumption step and then the evaluation step. Okay, so we are going to see if this formula is going to hold true for when n is equals to 1. So we say when n equals to 1, let's see. So what are we going to be having? We'll be having s subscript 1. That's the sum of the first term. And of course, what is the first term here? It's just only 1. So s subscript 1 is equals to 1. That's what we have on the left hand side. And on the right hand side, what are we supposed to have? In the place of n, we're going to be 1 bracket open 1 plus 1, then divided by 2. This 1 represents the n here, and then this 1 here represents the n here. This 1 is a constant, just as we have here, and this 2 is also a constant, just as we have it here. That is when n is equals to 1. So let's see. If we expand this bracket, we'll be having 1 plus 1, that is going to be 2. 2 times 1 will still be equal to what? 2. And then 2 divided by 2, of course, that's going to be equal to 1. So that tells us that when n is equals to 1, s1, which is equals to 1 on the left hand side here, equal to 1 also on the right hand side here. So we say the formula holds true for when n equal to 1. We can see that when n is equals to 1, the formula holds true. Okay, so this is the initial step or the basic step. Now we proceed to the inductive step. Now, but before we proceed to the inductive step, for your own proper understanding, let's see if this same formula is going to hold true for when n is equals to 2 and when n is equals to 3. Okay, of course, that is not part of our solution, but just for better understanding on your own part. So we say here on this other side of the board, when n equal to 2, what are we going to have? So we'll be having it to be s subscript 2 as we have here, and that must be equal to 1 plus 2, because these are the first 2 values, and that must be equal to, again, to this other side of the equal sign, we'll be having 2 bracket open 2 plus 1 close bracket, then divided by 2. Also, when we evaluate this is going to be 1 plus 2, that's going to be equal to 3, and to the other side of the equal sign, that's 2 times 1, that's going to be 2 plus 1, is going to be 3. Then 3 times 2 will be 6. And of course, 6 divided by 2 is still going to be what? 3. So this same formula holds true for when n is equals to 2. We can see that. Then next is when n equals what? Equals 3. So we'll be having S3. And for the S3, we are going to be having 1 plus 2 and then plus 3 on the left hand side of this equal sign. And that must be equal to, now when n is equals to what? When n is equals to 3. So we'll be having 3 bracket open, 3 plus 1 close bracket, then everything divided by 2. So let's evaluate that also. So we see that this is going to give us 1 plus 2, that's going to be 3. 3 plus 3 is going to be equal to what? 6. So 6 must be equal to 3 plus 1 is 4. 4 times 3 is 12, and 12 divided by 2 is going to be what? 6. So we can see that the formula holds true for when n is equals to 1. It holds true for when n is equals to 2 because we're having 3 on both sides of the equal sign. And then it also holds 3 for when n is equals to 3 because we're having 6 on both sides of the what? Equal sign. But like I said earlier, the only one you need for the base case or the initial step is just when n is equals to 1. These other two, you do not need them. Just for you to see that the formula holds true. Okay. So we'll proceed into the inductive steps now. Now, for the inductive step, we are going to be having case 1. Case 1. And what is the case for case 1? We assume that the formula holds true for some value k. Now, if the formula holds true for some value k, we'll put colon in front of it, and that tells us that s subscript k, as we have it in the place of n, s subscript k is now going to be equal to 1 plus 2 plus 3 plus list going on, and then plus k, because in the place of n we are putting k because we are assuming that it's holding true for some value k, and that must be equal to k bracket open n plus 1, sorry, k plus 1, I mean k plus 1 everything over what? Over 2. So this is the first case in the inductive step, case 1 of the inductive step. So in case 1, we will always assume that the formula holds true for some value k in the inductive step. So the next step now is to go to what? Case 2, where the bulk of our work lies actually. So we'll be having case 2. Case 2. So in case 2, we test, this time around, we are testing for when n is equals to k plus 1. This time around, we have to show that this formula holds true for when n is equals to k plus 1. We have seen for when n is equals to 1. We have seen for when n is equals to what? Equals to k. It is when n is equals to k that we have this particular one. So here we are going to test for what? When n is equals to what? K plus 1, to fully establish that this particular formula can represent this sum here. So what do we do in this case? Follow me. So we'll be having s subscript k plus 1, s subscript k plus 1, and that's going to be equal to 1 plus 2 plus 3, and then plus the list going on, plus k in this case. Then once we have k, we are assuming that there will be one more step, because this is where it stopped before, and that is the position here. Now, for us to have one more step, it means that we are going to add k plus 1. That's going to be bracket open, k plus 1, which is what we have here. So we are adding this to the left hand side of the equal sign in this case, and that must be equal to what we have here, which is a replica of what is here. That's going to be k bracket open, k plus 1 close bracket, then everything over 2. We have just repeated what we have here in this case, and since we have added this to this point, it must be added also to the right hand side of the equal side. that is k plus 1. Okay, so this is the evaluation step. Now, if this is going to be possible, if it is going to hold true, for us to be able to establish that it's actually hold true, we are going to manipulate this right hand side of the equal sign. And by the time we manipulate this right hand side of the equal sign, there is a target that we are going to meet. So you must know the target you are going to meet before you actually start your work. Because if you do not know your target, I tell you, your journey will be very far. Very, very far. Now, what is going to be our target? All you need to do to know your target is to study this pattern that you have here. Okay? Or you come and study this pattern that we have here. Now, what is going to be your target? Look at it. Your target is going to be something like this. Here we have n. And because we are actually trying to prove for k plus 1, so anywhere we see n, we have to put what? K plus 1. So the first step here has to be k plus 1. That's the first thing that we must have. And then in here, we have another bracket. So in the place of n, we are expected to have also what? K plus 1 in bracket. And then before it is now being added to 1 again, as we have it here. Close the whole of the bracket. Then everything divided by what? Divided by 2. And of course, if we simplify this further, you'll be having k plus 1 in the first bracket, and then k plus 1 plus 1, that's going to be what? K plus 2 in the second bracket. This is divided by 2. So I tell you, this is your target by the time you start evaluating the right hand side of the equal sign from that end. This is your target. Either this or this, but basically this should be simpler. So this should be your target. And once you know this is your target, you will know that your journey will be shorter in quote. Okay, so what do we do now? Our attention will now be focused on this right hand side of the equal sign. So what do we do? The denominator of this, of course, is assumed to be a whole. The denominator is going to be what? 1. So we are going to have the LCM of 2 and 1 being 2. So 2 divided by 2, that's going to be 1. And 1 multiplied by the whole of the numerator, we'll still be having k bracket open, k plus 1. And then plus 2 divided by 1, that's 2. 2 multiplied by what? The numerator there, that's going to be 2 bracket open, k plus 1. So that is what we have when we evaluate this, expressing them as a single fraction. Okay, now if you have foresight, like some intelligent students in our set or in my set while I was in 100 level, they will already see that, okay, this is like factorizing quadratic equation. And from here, you can just factorize k plus 1 is common to both of them. You can factorize that out and you can get to your answer very quickly. But if you were like me, that I may not be able to see it readily in this situation, I'm going to have to do something again. And that is to expand this one. Of course, the journey will be far, but it's actually going to be worth it. So when I expand this, that's going to be what? K squared plus k, and then plus 2 times k, that's going to be 2k, plus 2 times 1, that's going to be what? That's going to be 2. So everything divided by what? Divided by 2. And of course, that's going to be equal to k squared plus 3k plus 2, also divided by 2. So if you are like me when I was in 100 level, this is what I would have done. Then from here again, I will now say, what can I do to bring this format back to this particular format which I want? I'll now start factorizing again. You see that that journey is kind of long, right? But no problem. If it works for me, I am good. And this is going to be equal to, for me to factorize this, what number must I multiply to give me 2? And when I add the two numbers together, they will give me what? 3k. That's going to be what? K squared plus 2k plus what? K. This k is same thing as 1k. So 2 times 1, 2. 2 plus 1, 3. And then eventually plus what? Plus 2. Everything divided by 2. So what do? I bracket the first 2 here, bracket the next 2 here. And that's going to be equal to, what is common to these two? K. And brackets open, K plus 2. What is common to these two is actually going to be what? 1. That's plus 1. Bracket open. Also, K plus 2. Because K divided by 1 will be K. 2 divided by 1 will still be what? 2. And all of this still must be divided by what? Divided by 2. Now, I can see now that K plus 2, K plus 2 is common to both of them. So I can just bring out my what? The first one here is K. The second one here is plus 1 in the first bracket. Then this first one, take any of these two. That's going to be what? K plus 2. Then everything divided by what? Divided by 2. Now, if you check this, you will see that it is not the same thing as your target destination before you actually started the evaluation. Now, once you have been able to establish it to this point, then you can now draw your what? Conclusion. Because what are you looking at? By this particular formula, if the step goes one more, that's by n plus 1, this would have become n plus 1, which is assumed to be k plus 1 here. And this would have become n plus 1 plus 1, that's going to be n plus 2, which is assumed to be what? K plus 2 here. And everything divided by what? 2. And you have been able to achieve that by this evaluation that you have done. So like I said, you see that bulk of our work is on that what? Case 2 of that particular test. So once you have been able to achieve this, you conclude. You now say, therefore, since the formula holds for n equals k plus 1. Since the formula holds for n equals k plus 1, then the formula representing this is true. Then n bracket open, n plus 1 in close bracket divided by 2 holds true for 1 plus 2 plus 3 plus the continuous list, then terminating at the point what? N. So this is our conclusion, and that is the first question under proof by mathematical induction. It's very easy. Now let me give you the clue to this. Once you have been able to establish for when n is equals to 1 or whatever value n is starting with, you have been able to establish that it is true. The next case is what? The inductive step. Then you assume for case 1 when n is equals to k. So that's when n is equals to k. So that one is just assumption, and then you are good to go. The next step is case 2. And I tell you, basically, or the basic knowledge you need when you're working in this with this case 2, in most cases, is what's it called? Factorization. The same factorization you learned when you were in GSS2. The same factorization you learned when you were in SS1. The same factorization you learned when you were in SS2. That is all that is needed to be able to prove mathematical what? Induction. So this is question number 1. We'll be going through question number 2, and question number 2 will be very much faster than this, because in that situation we'll now have to do so many explanations before we arrive at our solution. So stay tuned for question number 2. Question 2. Prove by mathematical induction that 5 plus 7 plus 9 plus 11 plus 2n general formula plus 3 is given by this particular formula. This formula represents whatever sum you can get from here as when n open bracket n plus 4. Okay, so we have started already. Let's s subscript n to be equals to what? 5 plus 7 plus 9 plus 11. Of course, these are what? Odd numbers starting from 5. And this is the general formula for this particular sum. Okay, so the first case, that's what? The initial step. Initial step. When n equals what? 1. That's the initial step. So we're going to be having s subscript 1 equal to, the first thing here is just 5, and it must be equal to what we'll be having at the other side of the equal sign. That's going to be 1 bracket open 1 plus 4, and of course that's going to be 5 equal to 1 plus 4 is 5. 5 times 1 is going to be 5. So we say the formula holds true for when n equals 1. Okay, so inductive step. Case 1. Under case 1, we always assume that the formula holds true for when n equals what? K. That is, s subscript k must be equal to 5 plus 7 plus 9 plus 11 plus bracket open, sorry, before the bracket opens, plus dot plus bracket open 2n plus 3. That must be equal to k bracket open k plus 4. So we assume that the formula holds true for this particular one. Pardon me a little, please. I have a little error in here. I have 5 plus 7 plus 9 plus 11. Then I'm supposed to have plus continuous list before it now ends at this particular one. So that is what I'm supposed to have first of all. So before I now have the other one. So pardon me as I correct that very quickly. Plus dot and then plus 2n plus 3 equals to n bracket open n plus 4. Okay, I think that's nice now. Looking nice too. So once we assume for this particular one, the next thing is to go for what? Case 2 under the inductive step. And the case 2 is where we show that the formula holds true for when n is equals to k plus 1. Then that's what we want to show, that the formula was true. Okay, now before we proceed to this particular one, find a place in your jotter and quickly try to evaluate for when n is equals to what, k plus 1 in this case. So that's going to be equals to 2 bracket open very quickly. Sorry, not 2 bracket, yes. 2 bracket open k plus 1 and then plus what? Plus 3. This is what we are going to add. 2 bracket open k plus 1 and then plus 3. This is what we are going to add to the first side and going to what? Add to the second side, because this is one step forward because of n equals to k plus 1. That's anywhere we see n here, we'll be representing it by what? K plus 1. So we'll add this to this left hand side and we also add it to the right hand side of the equal sign. And when you have added those, what is going to be your target at the end of the day? Remember, I said before you proceed to even evaluating, there must be a target for you. So what is going to be your target? Your target is going to be on the right hand side. So your target should be something like this: n plus 1, oh sorry, k plus 1 representing the first n, and then for the second n, k plus 1 first of all for representing n before it is now being added to what? Added to 4. And when you work these two together, you'll be having k plus 1 in first bracket multiplying k plus 5 in the second bracket. So this definitely is going to be your what? Target at the end of the day. So we want to show that the formula holds true for when n is equals to what? K plus 1. So we proceed as follows. So that's going to be s subscript k plus 1, like we had it, must be equal to, and the first step is going to be 5 plus 7 plus 9 plus 11, and then plus, the list goes on and on, plus 3 dots, dot, and then plus 2k plus 3, first of all, before you now say plus this particular one, 2 brackets open, k plus 1 representing the first n here, and then plus what? Plus 3. So this is the next thing that we are adding, just as we have it here. And once we add this one to the left hand side, it's also going to be added to the what? To the right hand side. And for the right hand side, what are we going to be having? We'll be having k bracket open, k plus 4 firstly, and then added to 2 brackets open as we have it here, k plus 1 and then plus 3. Okay, so the whole of this one must be simplified in such a way that we must arrive at this particular solution, which is our target. Once you have been able to what? Simplify to this one, and this one is kind of what? A representative of what we have here, with one step ahead, that's one step further. So n, one step further of n is n plus 1, that's why we have k plus 1. N plus 4, one step further of n plus 4 is what? N plus 5, that's why we are having k plus 5 here. So you must be able to what? Evaluate this particular one to come and meet this your target that you have here. So what do? We proceed as follows. All we need to do, remember, if you are like me when I was in 100 level, I like to what? Simplify everything out, and then after I've simplified those things, then I begin to pick them one by one until after you have grown to a particular level, you have matured to a particular level, then you can begin to see what you can do even before you finish your what? Simplification. So what am I going to be having here? K multiplied by k, that's going to be what? K squared plus 4k, and then plus 2 times k, 2k, your urgent 2k. Remember that. Then plus 2 times 1, that's going to be 2, and then plus eventually at the end of it, that's going to be equal to what? 3. Okay, so let's simplify things out quickly before we now begin to do the next thing. So that's going to be what? K squared. 4k plus 2k, that's going to be what? Plus 6k. And then 2 plus 3, that's going to be what? 5. Okay, so this has become what? A quadratic expression. So this quadratic expression will have to be what? That's what we have to factorize. And when you want to factorize that, you're going to look for two numbers such that when you multiply them, they'll give you what? Positive 5. And when you add them together, they give you what? Positive 6. And those two numbers are actually what? 5 and what? And 1. So you'll be having this to be what? K squared by plus 5k by way of factorization, and then plus k. 5k plus k will be equals to 6k, and then plus what? Plus 5. Of course, put them in bracket and factorize. That's going to be k squared plus 5k in the first bracket. Then in the second bracket, sorry, we have plus. In the second bracket, k plus 5. Okay, so that's going to be what is common to these two is just what? K bracket open, k plus 5 in the first bracket, and then plus what is common to these two, of course, is just what? 1. So that's going to be 1 bracket open, also what? K plus 5. And in that situation, what are we going to be having? These two brackets, they are exactly the same thing. So you just want to factorize because they are common to the two. So you have k plus 1 in the first bracket as we have, and then k plus 5 in the second bracket. Now, we have been able to bring this particular one to this format. It means that our goal has been achieved. K plus 1, one step forward of n plus 1, k plus 1. K plus 5, one step forward of n plus 4, n plus 5, k plus 5. So since we have been able to see this particular one, since the formula holds true for n equals to what? K plus 1, then n bracket open, n plus 4 is the general formula for the sum 5 plus 7 plus 9 plus 11 plus the ongoing list until you get to some particular odd number given by the general formula to n plus 3. So this is our conclusion. So you can see this one is much shorter than question number 1. Why? Because there are no much explanation to this one like we did for number 1. I had to do that for number 1 so that you can get the basic understanding of this particular concept. Okay, so these are method or the proof by what? Mathematical induction. I'll be making more videos on this particular concept. Of course, I'll be giving even more difficult question. I'll be walking through more difficult questions than what you already have in this first two. But it is very important we start with this very first two, which actually are the simpler forms or the simpler concept that you can come across the mathematical induction. And then from this knowledge, you cannot transfer the knowledge that you have gotten in this particular one to the seemingly much difficult ones than this one. And I tell you, it's going to be a beautiful experience. Thank you for your time. Enjoy your day.